So at this point, after you've done your checks, all your stuff is loaded in, you may be wondering, oh gee, how do I rendezvous with the target vehicle? Well, it's very simple. Step 1, you need to request a circularization at your periapsis. The Gemini in real life doesn't perform a Hohman transfer maneuver, but in reentry, it does. And this requires a perfectly circular orbit in order to work efficiently. So let's get our circularization at our periapsis. Click this button.
Roger, DCS.
And now you may be wondering how to translate all of that. Mission tools. Catch-up maneuver pad. You can use a scroll wheel and punch numbers in. So you can see this will translate your ground elapsed time of ignition, your delta V's, burn time, attitude, all that. I don't need it though. So you'll acknowledge the DCS receive with that button and clear the computer. 0, 1. This is the hours and minutes time of ignition. So it should say the first GETI right here, 00111, matches 00111. Good. Clear. 0, 2, readout. 02737. 02737. Good. Clear. Now check 25. 90750. Now this is not 90,000 feet per second. This is actually negative 750. The computer doesn't have a minus, so you can see 9 has a minus above it, signifying that if a 9 is in the first digit, it implies it's a negative number. So that matches. 26 is all zeros, good. And 27. You can see negative 0, 0, doesn't matter, it's all the same. You can see if you insert negative 0 manually, you still get 0 in return, right? Now we're up to burn time. There is no computer stuff for the rest of it, so this is just for your own information. The attitude doesn't matter because in reentry, all burns in Gemini are performed impulsively as opposed to like Apollo. So we'll cover that. Our altitude after the burn. And here's the short summary, the brief version. 75.03 feet per second. And our burn time. Now at this point, here we go. Inertial guidance system to sharp and forward. Now we can see our prograde attitude. And we can turn on the ohms, and I can show you what this does, right? If we go rate command, we get manual control of the spacecraft, like so. If we're on sharp and forward and platform, you can see the spacecraft's automatically going to align to 0 pitch and 0 yaw, but notice it does not correct the roll. Needs to be done manually. Now, we just need to perform the burn. I always do this on rate command. And there'll be a reason for this, which we'll talk about closer to the burn. So we'll take a look at our transcript. And here we can see our burn time. So let's approach that 1 hour mark. Here we can see we're close to our burn. So let's start the computer. And you could use the event timer. You could also use, for the computer, it has its own timer for these burns. If we take a look at the memory core, we can see time of ignition is on core 84. And we can see computer is counting down to ignition, but you need to keep spamming readout. It's much easier setting the event than setting the event timer to just look at this and look at the transcript and see 1 hour, 11 minutes, 27 seconds, right? When we get close to the burn, we want to make sure that we're facing really good prograde. We can see we are facing decently good prograde. As we get closer to the burn, we can see the up-down is transferring to forward-backwards. And this is exactly what we want. Now, here we are. Make sure ohms control's on, rate command, computer running, sharp end forward. Sometimes the comp light doesn't come on. It's just a glitch. Here we go. 7, 6, 5, 4, 3, 2, 1, ignition. See, now the computer is running. And now you cannot burn in any direction or in more than one direction at once. So instead of burning entirely impulsively, I like to use the attitude to sort of stabilize things here. Unfortunately, I was talking about that, so I didn't have time to do it. So we'll just burn impulsively, which is burn all in one direction, then the next, and then the next. And this is impulsive. You burn your forward, backwards, left, right, up, and down. Whereas controlling the attitude with the burn, this is not impulsive. This is a controlled style burn, more like the Apollo program. So that is how you do the first part of orbital insertion. At this point, you reset the computer. And now, of course, CO2 needs to be managed. And now begins the next part. So this will be part 1 of a 3-part demonstration.